You can store data in OneTick archives, in OneTick's native format, or in Parquet. Historically, when you're storing in Parquet, you stored those Parquet files in a OneTick-like structure. Now you have the additional choice of storing Parquet files in a Partitioned Parquet structure, meaning it's easier to read that Partitioned Parquet structure from, let's say, Python using Pandas, whether you're using PyArrow or using FastParquet, or other tools that can read Parquet files. Okay, in our locator, here I've got three databases. First one is a standard OneTick database. Second one is our traditional way of writing Parquet, where the archive format is set to Parquet. Third one, again, archive format is set to Parquet, but now we have Parquet use partitioning set to true. So we're going to create a partition structure. So I've run loaders for each of these two, taking my source data and reloading it into Parquet, or loading it into Partitioned Parquet. Now the loading of data into these is identical to loading any other data. So let's look at what the Parquet structure looks like within OneTick tools. So our existing database, we drill into the database, see the list of symbols, and see the list of tick types. Our Parquet database, again, symbols and tick types, and retrieve the data. Our Partitioned Parquet database looks slightly different. In this case, it's got a little plus. Expand the plus, we can see underneath there's a database per tick type. This corresponds to the Parquet structure underneath. So let's look at trades. Underneath the trades, we see the symbols. And now we see the data. So again, from within the OneTick toolsets, or using OneTick APIs, it appears like a OneTick database, but under the surface, we're actually just creating a partitioned Parquet structure, which any tool that can read Parquet can read.